On August 20th, 2026, the biggest argument about neural rendering in games wasn't in a conference keynote. It was in practitioner threads where technical artists, three-dimensional artists, and legal-minded developers were asking a less glamorous question: can this generated asset actually ship? The same week, Microsoft said it planned to eliminate 3,200 roles across Xbox, and Makers Fund closed a $250 million round to expand its game industry footprint. Studios were trying to decide whether learned models should be part of their render pipeline, their asset pipeline, or their legal risk register. That collision is the real story. Neural rendering has stopped being a graphics demo. It's becoming a production system, and production systems fail at the seams. Frame budgets, memory, authorship, contracts, and the human judgment that says, this is the game we wanted to make. I'm with MonsterPixel Labs. If you're new here, we break down what's actually happening in game engines and gaming tech, and what it means for your work. If that's your kind of thing, hit subscribe and drop a like, because it genuinely helps this channel reach the people who need to understand these shifts before they become deadlines. To understand why neural rendering is suddenly a production problem, start with the pain it's trying to fix. For decades, the engine's job has been to turn art into frames. Artists build meshes, paint textures, author materials, and programmers write shading models that approximate light. That worked, but it cost real money. A large environment in a AAA title can carry gigabytes of texture memory, and every extra surface detail competes with streaming, animation, physics, and the frame time target. When a team wants a worn stone wall to look like hand-painted variation, or a metal prop to catch reflections the way a concept artist sketched it, the old answer is more handcrafted data, more texture maps, more material variants, more lighting bakes, more technical artist hours. The bottleneck isn't that artists can't make beautiful things. The bottleneck is that the engine's traditional representation is explicit, and explicit data doesn't scale for free. Neural rendering changes that representation. Instead of shipping every detail as a texture map or a handwritten shader branch, a trained model can learn a function. A neural texture model, for example, can take a position, a normal, a UV coordinate, or a small amount of scene state and predict albedo, roughness, or normal detail. A neural radiance model can approximate illumination or reflections from scene inputs rather than tracing every ray. In plain terms, the model becomes a compressed memory of appearance. That's why it can be attractive. It can trade storage and authoring time for computation, or it can trade expensive lighting calculations for a learned approximation that's fast enough for the platform. But here's the first catch. A learned function isn't a texture. A texture is data you can inspect, slice, compress, and hand to the material system. A neural model is a behavior. It can be globally plausible and locally wrong. It can drift when a character animates, when a light moves, when streaming loads a new region, or when a platform has less memory than the test machine. So the moment a team wants to use neural rendering in a shipped game, the question changes from does it look good in the demo to can we schedule it, validate it, and defend it? That's where the production system appears. Think of it like a kitchen with a very fast sous chef robot. The robot can plate dishes quickly from a recipe, but the head chef still sets the menu, checks the taste, controls cost, and decides when the robot is allowed to touch the pass. In a game engine, the neural model is the robot. The artists are the head chef. The technical artists define the inputs and outputs the material system can consume. The engine programmers decide when inference happens. The producers and legal team decide whether the output can be shipped. If any of those roles is missing, the dish may be fast, but it may not be the restaurant. Let's walk through a concrete case. Imagine a team working in a general-purpose engine such as Unreal Engine, Unity, Godot, or Roblox, and they want to reduce texture memory for a large, persistent map. The art director defines the look: mossy stone, worn metal, hand-painted variation, no plastic seams. The technical artist chooses a small model that maps three-dimensional position and UV coordinates to albedo, roughness, and normal detail, because those are the surface properties the engine's material system needs. The model is trained on approved reference textures and artist-made variants. Every source is logged, because later someone in legal or procurement will ask who made the data, who licensed it, and whether a contract says content generated by artificial intelligence is allowed. Now the integration. The team doesn't simply run the model every frame. That would be a frame time gamble. Instead, they schedule inference at bake time. The engine calls the model to generate texture tiles or material parameters, then caches the results as standard assets. At runtime, the game falls back to those baked textures. This is the key move. The neural model isn't replacing the renderer. It's feeding the renderer. The engine still handles culling, animation, shading, post-processing, and frame pacing. The model just changes how some of the data gets into the pipeline. This design choice is what separates a research result from a production system. Inference scheduling is where many teams quietly fail. A model may be accurate offline, But if it runs per frame on a console with a tight thermal budget, it can break streaming, spike memory, or make the game stutter exactly when the player turns a corner into a dense area. So the team benchmarks not just quality, but cost. They measure memory, central processing unit time, graphics processing unit time, streaming overhead, and fallback behavior. They test extreme angles, dynamic lighting, platform constraints, and long play sessions. They build a regression test that compares new model outputs against an approved reference, so a future model update can't silently change the look of a level. Then comes the part that's easy to miss until it becomes a deadline: production governance. This is where the legal and authorship pressure from the current industry moment hits. Practitioners have raised concerns about clauses that restrict artificial intelligence, copyright uncertainty, and human authorship. In a commercial project, that means a neural texture that looks perfect may still be blocked if the model's training data is unclear, if a publisher guideline says generated art requires human review, or if a client contract demands defensible human authorship. The team therefore documents provenance: which artist directed the output, which references were licensed, which model version was used, what parameters were chosen, and what human review changed it. That record isn't bureaucracy. It's the difference between an asset that can ship and an asset that becomes a lawsuit, a union dispute, or a broken license. This is why the broader industry signals matter. Microsoft's planned reduction of 3,200 Xbox roles and the protests by union workers across North America show that senior graphics, systems, and artificial intelligence talent are becoming harder to retain. Makers Fund's $250 million round shows capital is moving into creator infrastructure, where pipelines enabled by artificial intelligence may be funded, but also where the pressure to produce more with less will be intense. PlayStation scaling back live service ambitions for Horizon Hunters Gathering and reassigning developers is a reminder that content-heavy pipelines carry real feedback risk. New studios like Black Pony Immersive, led by Harvey Smith and fellow Arcane Austin veterans, point to a market appetite for premium authored experiences, where neural rendering may assist art direction rather than replace it. None of that's a graphics headline. All of it shapes whether a neural pipeline can be staffed, funded, and defended. So what does this mean at your bench? If you're a technical artist, the practical move is to stop asking, can we train a better model, and start asking, where does inference happen and what happens when it fails? You need a fallback path, a budget, and a way to inspect the model's output the way you inspect a texture: seams, normals, lighting response, streaming cost, and the behavior when a level streams in late. If you're a three-dimensional artist, your leverage is in defining the target look and reviewing the output. A neural model will happily produce a plausible wall that isn't your wall. Your job is to make the model serve the art direction, not the other way around. If you're a game designer, think about persistent world state. Large maps with permanent player changes are becoming a real bottleneck, and neural methods may help generate or compress that state, but they also create synchronization, storage, and consistency problems. If you're a developer or technical lead, treat the model as a dependency with a version, a license, a performance profile, and an owner. If you're an art director or producer, review vendor and internal tooling contracts now before the first generated asset looks good enough to ship. The honest answer is that neural rendering isn't ready to replace the engine's renderer. It's ready to become part of the engine's production system. If a team is willing to build the unglamorous parts, data provenance, inference scheduling, fallback assets, regression testing, legal clearance, and human sign-off before the next patch, the next contract, or the next platform target, the teams that'll use it well won't be the ones with the biggest model. They'll be the ones that can explain in a post-mortem why the frame budget held, why the art direction survived, and why the shipped asset could be defended. So return to that August thread where the question wasn't, what can the model render? But can we ship it? That's the whole shift. Neural rendering is no longer a trick that makes a frame look magical. It's a production decision, and the production decision is where the game is won or lost. If this gave you a clearer way to think about neural pipelines, a like and a subscribe genuinely help, because this channel runs on people who find this stuff worth their time, and that support is what lets us keep digging into it. Anyway, that's the briefing for today. See you in the next one.